Okay, well, yeah, my name is Rob Riali. I'm the marketing director for Sniffer Robotics. I've been in the building materials sustainability space for the last 20 years. A lot of construction materials, solar, and actually worked with my prior company. We developed solar landfill caps, and so I've been with Sniffer Robotics for about a year and really embrace the mission here of helping curb uh, greenhouse gases emissions and playing our part in this role. So I appreciate the opportunity to present here, and I actually love how conversational it's been. So while I do tend to get on a roll, I'd love everybody just to jump in and share anything that you want to discuss. So the first thing I want to talk about is the new regulations that are coming to Canada, you know, very soon. So compliance obligations beginning January 1st, 2027 for open and closed landfills. Okay, and this is part of the Canadian government published 2030 emissions reduction plan. So providing a roadmap to reach its climate commitments, including reducing greenhouse gas emissions by 40 to 45%. And that's below the 2005 levels. And so they want to get to 50% of the 2019 levels by 2030. And so they're proposing some new regulatory framework and encourage everybody to get familiar with them. I'm certainly not an expert, but I can speak to what the ECCC is looking for when it comes to compliance related to surface emissions monitoring. Okay, and so these regulations will enforcement will begin on January 1st, 2027, but make sure you understand any pre-work that can be done and think about things that you can do prior to the regulations because you can do things now penalty free, and you can do things to prepare so that as the regulations come in, that your site can be in really good shape, right? So, what are they looking for? They're looking for compliance, surface emissions monitoring for any single location that gets identified as emitting over 500 parts per million. And then they're looking for 4,500 square meter grids that in aggregate total more than 25 parts per million, right? So on the first one, that could be an area with high concentration. The second one is likely to be multiple leaks with lower concentrations that are, still creating a lot of those greenhouse gases. They're looking for monitoring 3 times per year at 7.5 meter spacing. And so as I go through, you'll certainly see what that spacing looks like if you're not familiar with that now. So for the inspection methods that they have in the draft regulation, they've approved two methods, Method 21 and OTM 51. And what they're really doing here is in a rare occurrence, the Canadian government is mimicking the U.S. government in terms of any type of green regulation. Typically, Canada is ahead of us in the States, but this is one example where they're following our lead. And so in the U.S., a lot of the federal regulation calls for 30-meter pass spacing, but then some states are requiring more tighter spacing to get more accurate data. So the Western states, Washington, Oregon, and California, and now Colorado. So I share that with you because really it's trending towards what Canada is adopting is really what where things are trending both in the States and elsewhere. So talk a little bit about the different technologies that can be deployed for identifying methane sources, right? And so this is actually a graph. It was created by the Rocky Mountain Institute, but then they credited Sniffer Robotics. Basically, they took one of our graphics and they made it look really cool. So on the left-hand side of that dotted line, that's what is compliant, right? That's regulatory monitoring. So there's your two methods. First is method 21, and that's a manual process. And the second is OTM 51, which relies on a drone. They're both collecting emissions at the ground source level, at point source. And then everything to the right are different ways to identify methane plumes. And, a lot of them are ambient air measurement systems, right? So there's a couple different drone technologies. One is the tunable diode laser, and that's basically putting a beam into a column of light, and it's looking to identify the different path integrating sensors. So that can measure parts per million per meter. But again, that's in air. That's not at ground surface level. And then there's the ambient air measurement that you see here on the right side here, and that's in plume sensing, and that's flying a vertical and horizontal path. That's capturing, in air methane, and that's measuring in cubic feet or kilograms per hour from the landfill. So any of those models, any of those type of different measuring systems, what they require then is modeling systems that calculate different, environmental conditions. That could be wind or moisture. And then they're trying to model that and say, we think we've identified the leak source to be somewhere around, X. Whereas the two methods that are approved for compliance, they don't rely on monitoring because they've identified the leak at the source. And then, of course, we have satellites, right? And so satellites are out constantly scanning. A lot of these were launched really to look at the oil and gas industry to try and find these large super emitters. And so, in fact, there's one up in Canada, headquartered in Montreal, that's launching these satellites, and they're kind of like watchdogs, and they're blowing the whistle and reporting these to regulators and getting any press they can. And so what these satellites are using is hyperspectral imaging. So that's capturing the light, again, very similar to the TDLS. They're shooting that down, they're capturing light in that column, and they're measuring that, and they're taking an average of the methane concentration throughout the entirety of that column. And so they're reporting in, you look at this image on the left, okay, and it's pretty pixelated. And so they're reporting in either 50 meter square pixels or 30 meter square pixels. And so it depends on the satellite. And this example here is 50 meters and pixel samples. So as you look through it, you can see the lighter areas are identifying higher concentrations of methane. And so this is an image pulled directly from that website, and there's a landfill behind it, and you can see there's a big plume of methane. The difference is in that middle image, what you're looking at is that's the difference between surface emissions monitoring and any type of ambient air, right? Is in that middle image, you can really see the point sources, where those leaks were, and you can see the concentration levels and the data that was collected. And so that middle image was collected, the data was collected through the Sniffer drone, the product that Sniffer Robotics makes, and was then all the data conversion and quantification was done in our GIS platform. Okay, and then on the far right, what you're looking at is that would be your compliance image. Okay, so that will show you the exact point sources where those leaks, were found. So I think when you look at the satellites, we like to refer to them as like the canary in the coal mine. They'll tell you there's a problem, there's something going on, but then you have to go back and you have to figure out where those problems are and you have to investigate. They're trying to get to the point where they can model and tell you where the point sources are for the leaks, but they're just not there yet. Um, so for those reasons, any ambient air measurement system has not been approved for any type of compliance, whether that be US, Canada, or elsewhere. So what's interesting about this image here is we actually flew this site the same week that the satellite flew the site, or captured it rather. And so if you look at the image on the left, you could easily think this is a super emitter. This site has some serious issues. But then when you get down to the brass tacks and you look at the point sources, yeah, you can see there's some red areas, there's some hot spots, there's some things that have to be addressed. But overall, it's a very well run site, and you're not seeing a systemic issue. You're seeing something that you can really address and that you can remediate. And so what becomes important, I think, is when you have this type of data, if you've been flagged by a satellite, so this type of data can either defend, where you stand. It can validate, okay, the satellite made it look like there's a real problem. Or, it can be used to prevent being hit by that satellite to begin with, because if you have this data, then you can go remediate. So it's just real helpful to see, okay, this is the situation, this is what we have to address. So moving into the compliance methods, the traditional method here, it's been around forever. It's called Method 21. And so what you have is you have a person walking that site. They're supposed to be walking in, a serpentine path. In Canada, that would be that 7.5 meter spacing. And so they have a CH4 detector at the end of that rod. And, they're looking for any hits above that threshold, right? So, 200 parts per million or 500 parts per million. And so what's important to note about this process is a couple things. One is that CH4 detector should be less than 5 centimeters off the ground. And just looking at this image, you can see that that's not happening as consistently as the regulation states. So, some inspectors do better than others, but it is open to, human, I don't want to say error, but inconsistency. And the other thing is, in part 8.3, what that's calling out is that these CH4 detectors don't detect it in real time. So what this inspector should be doing is looking at the meter as he's walking, which in and of itself is a little bit dangerous. And when that meter hits the top of the arc, he needs to stop and hold that detector in place for 8 full seconds to get a complete reading. But per the regulation, they say you should hold it for twice that amount of time. So he should be stopping and holding that meter in place for 16 seconds. You get your reading, you record the concentration, you record the lat long, you plant a flag, you move on to the next step. So that's what the regulation calls for. But Method 21 certainly is open to human error and potentially some inconsistencies. So then we get to OTM 51. And so what that is allowing is to use a drone in place of the human that's going around and collecting those readings following that serpentine path. Okay, so but an important thing to note about OTM 51 is, so using the drone, while the CH4 detector in the drone runs at 3 hertz and the handheld runs at 1 hertz, so it's 3 times more powerful. It's still not running in real time, but it is using an algorithm to identify those leaks. It will mark that leak, and then per the regulation, that has to be manually verified. So the method, OTM 51 method, once those points are identified, we'll send a person out there, and will walk a spiral path until they find the exact precise location of that leak. Again, the same thing as I mentioned in the prior slide. You measure, you hold it for that 16 seconds, you record all the data, the concentration, the lat long, you plant your flag, which is also going to be marked in our GPS platform. So, you can pull up your mobile app, it'll direct you directly to that point. So that can be both for the inspector and for remediation. And here's what it looks like. So the drone is flying at a constant 7 miles per hour. It's dragging a hose. That hose has a weighted nozzle at the end and that's where the vacuum is that's sucking those air samples up to the drone. It's using laser guided terrain following to ensure that it's a constant 7 meters above the ground. So as the landfill terrain undulates, the drone will follow that. And it's collecting 3 data points per second. Okay, it's also measuring wind speed and all kinds of atmospheric conditions. And so it's collecting that data as it goes. And it's always tricky streaming video, so hopefully this comes through okay. But this is what it looks like, and you can see it's a fairly steep terrain, and the drone's flying it with no problem. It's dragging that weighted nozzle with the CH4 detector, and you can see that nozzle is staying at ground level. So this was designed specifically to meet compliance. And so there's a couple reasons for the weighted nozzle. First is what I just mentioned. We need to keep it at 5 centimeters or below to collect those ground samples. The second is to get through heavy vegetation. So we inevitably get the question, what happens if the hose gets snagged? It does have a quick connect breakaway. So if that were to happen, and it's we've flown over 150 sites, and it's happened fewer times than I have fingers. The technician can go out and just simply grab that hose, reattach it. Or if it's in an area where it's not safe to get it, well, then just put a new hose on. The other part of manual verification here is you can see the wellheads. The wellheads have to be manually verified, every one of them. And so, when you look at the entirety of a landfill and the amount of land that a human's being asked to traverse versus the area where they have leaks, you can see there's not a lot of benefit to walking that entire thing. You can use the drone to capture, 85, 90% of the surface area. You can send a person out to manually verify all the hits as well as the wellheads. So it's a tremendous efficiency gain and a safety gain as well. And so when we look at the two methods side by side, if we look at a 40-hectare landfill, the human has to walk that terrain. There's going to be some variability in the path that they walk. There's going to be inconsistency in the spacing, and there's going to be hazardous terrain that they can't even get to. And again, from a safety perspective, probably should not go to. Whereas the drone is going to do it in about 30-40% of the time, and it's going to get to a lot of that hazardous terrain that you may not be able to get to otherwise. I will tell you, down here in the States, there's been a little bit of gamesmanship where certain bad actors have reported 30 to 40 to 50% of their landfill is hazardous terrain, and therefore they have no data to report. The US EPA is really coming down on folks who are doing that. And so I certainly wouldn't recommend looking at that as a positive loophole, because it is being noticed by the regulators. So we talk about the consistency of the spacing, right? There's consistency of spacing between the path itself. Are you collecting the data at that 7.5 meter spacing? But then there's the consistency of the data points along the path, right? And so again, when you talk about that drone flying a constant 7 miles per hour, getting those 3 data points per second, it's a lot trickier with a human. So if you think about it, if you go out and you exercise, you run, you bike, you walk, and you use your smartwatch or your smartphone, what do you get when you hit, kilometer number 2, kilometer number 3? You get it, they call it split pace, right? So you walk your first kilometer at this pace, your second at this pace, and that's because humans move at variable speeds. Even the best of us. And again, when you think about moving into terrain and stuff, so you're going to see inconsistency between the data points you collected. And so why is that important? That's important because for compliance, you're going to be asked to do that 3 times per year, and you're going to be asked to use comparative data. And so if you're not collecting the same data from the same data points, you could lead to a lot of inconsistency, and then it can kind of become a game of whack-a-mole. Well, we found gas here at one inspection, we didn't find it here, and vice versa. And again, that could be driven by collecting data inconsistently or at different places. And then there's the reporting component. With the OTM 51 using the drone, it's uploading that data directly to the cloud. It's recorded in a customized GIS reporting software. And if you want to download the app, you can actually see the hits happening in real time. So there's a consistency component and there's a speed component. And then, of course, there's operational risks, right? From a safety perspective, Method 21 certainly is not hazard free. The different, slip, trip, fall hazards and different emissions that they're exposed to for a longer time. And that's not just methane, that could be H2S or other, pollutants. So then we take a look at the data collection, and I love this image with all the different colored, what those are is flight paths. Okay, so it's based on battery life. And so any technician will come with multiple sets of batteries and remote charging capabilities. But they're pre-programming these flight paths before they ever get to the site. And again, the beauty of this is this flight path is exactly what that drone is going to follow. It's going to follow it today. It'll follow it tomorrow, a week from now, a year from now, 10 years from now. So it's about that consistent data collection. And then, what you're seeing is those geospatial buffers down there in that middle circle. Those are all those data points that it's collecting along the way, those 3 data points per second. And when you get into the software, you can tap on any one of those data points and get the exact concentration and the reading that was pulled from there. And so this is what it looks like in practice. On the left-hand side, those green dots, those are your data points, your kind of your breadcrumb trail, right? And so on the second image, that yellow circle is the drone says there's a hit. The drone found a hit, above that 2,000 parts per million or 200 parts per million, excuse me. So then, the technician uses the app. The app navigates them directly to that point. They walk that spiral path, and they've identified the exact precise leak location. They got a measurement. They marked a lat long. They planted a flag. So that's how the process looks in action. Additionally, the drone has the benefit of the capability to attach a 4K camera. So, the technicians are trained to identify any predictive areas for, potential leaks, right? So that could be soil erosion, that could be cover integrity, issues around the well or, potentially the penetration. So what they can do is at any point in time, they can take that drone, they can manually override it. So they've deviated from the pre-programmed path. They've snapped a photo or multiple photos. They caption those photos, mark the lat long. And so those will be automatically added to the report. And then they can send that drone to go exactly where it left off on that pre-programmed path and continue its inspection. So, again, a real identifier of maybe potential future problems or, areas that need remediation. So the daily reports are generated. These are available next day. And, up in the top right, that's just kind of showing you all the different hits and the concentrations. And there's multiple ways that this data can be aggregated and provided. So certainly, there will be the kind of list of all the hits, where they were, what the potential root cause was, what were the parts per million, as well as the verification, along with, full color imagery that shows you exactly what we're seeing. What you're looking at here is this is that integrated grid view that's part of the ECCC regs. Right, so any red area is an area that would be identified above that 25 parts per million for the average concentration in that 4,500 square meter grid. So look, this is more of a compliance thing, right? And I think it's helpful from our standpoint. We think the point source data is a lot more valuable to you as operators. To help you get in and address those areas of concern. But you will be required to provide this reporting. So again, using the drone, it's what happens as part of the data transformation on the back end. And here's a look at that Sniffer Field Ops app that I talked about. And so what you're looking at here is you can see all the hits. And so what those different shapes and colors represent is the center of an area is the hit the first time, and then each additional manual verification. So the center is probably red. On the right-hand side, it got green. That meant that the problem was resolved. If it turns red again, maybe it reappeared. It's tough to see here, but it's very helpful. And for a compliance standpoint, that's what they like to see. What's important to note here is that any rechecks, right? So per the draft regulation, you get a hit, you're required to remediate that within 30 days and do a recheck. All rechecks are done manually. While the drone could certainly be flown another time if that's what you were looking for as a site manager, just for the sake of a recheck, the drone doesn't need to be redeployed. So that, per the regulation, you are allowed to do that, or you could work with a partner to go do those rechecks for you. And again, looking at some of the different ways the data can be provided. So the left-hand side, that's your compliance view. Your yellows are hits above 200 parts per million. Your reds are hits above 500 parts per million. But then you get into a little bit more information when you look at the second one. That's the interpolated map. And so that will show you anywhere from 1 part per million all the way up to 100% methane concentration. And so again, that's really useful. So for compliance, if it's below their threshold, no, you don't have to report that. You don't have to share that. But you still probably want to know about it because that can identify you future issues that you might want to address. And the third one is a gas migration chart. And so that's that comparative data, right? That's showing you what it looked like last time versus what it looks like this time. So anywhere you see a red dot, you're seeing an increase in gas. Anywhere you see a blue, or I should say blob, you're seeing a decrease. So that can tell you a few things. That can tell you if the gas is migrating. That can tell you how effective your remediation efforts are. And again, identify future trouble spots. And on the right is estimated fugitive gas emissions in SCFM. And so just kind of moving away from compliance, there's a lot of value to collecting this data. So what you're looking at here is a landfill that was installing a gas collection system. And the project ran from January to March. And so what they wanted was to get a study to find out, where the high concentrations of methane were and help determine where to sink their wells and how to design their system. So that was done in January, and that red area is an area of real high concentration. There's a lot of gas there. So they're certainly going to focus on that area. So they're midway through the process. We flew it again in February. Come March, the system's running. They're pretty excited. They think everything is where they want it to be, but we found there's still that big pocket of uncollected gas. And so when you look in the kind of that red box, what we're doing is we're taking the mean or the average of gas emitted throughout the entirety of that landfill. And so it's at about 10 parts per million. So seeing that they still weren't collecting this gas, they made a few tweaks to the wells. They put in a few horizontals. We went back in June, and we're effectively hovering around zero for the mean of parts per million. So it's using these insights to make sure that not only they're addressing leaks but collecting gas, right? And so in the RNG world, that gas is money. There's a lot of value being associated to that gas collection, cleaning it up, putting it back into the environment as renewable natural gas. Another cool story. A customer had an environmental engineer come out to their landfill to design a gas collection system. And because the north area had been closed a lot longer, um, they just determined this is where you're going to collect the most gas. They're going to design the system to be heavily focused on the north area. We came out and flew the site and said, there's been a lot of gas migration, and we're seeing very little in the north. What we're seeing is we're seeing a lot of gas in the south area. Well, they didn't believe us. I don't know if they didn't believe us or they installed the system anyway. And kind of the joke we make is that they spent hundreds of thousands of dollars to prove us right. And so they did end up having to go back and expand that system and make sure they're collecting the gas out of the south area. So um, I know that today's focus was about the new regulations and compliance. So I wanted to spend the majority of my time focusing on that. But I did want to share that, as you are partnering and installing these gas collection systems, there's a tremendous amount of value in this data, um, for that process as well. And then just talk a little bit about sniffer robotics. So we've been around since 2016. We got EPA approval in 2021 down here in the US, and that really helped our business grow. We have locations throughout the United States. In Canada, we operate through partnerships. So we have two partners and likely to add more. And so what they're doing is they're using our technology, and so they're leasing our technology. It gives them access to our drone payload. It gives them access to our software platform, and they're going out and they're doing the work and they're conducting the studies. And so it's if you were to choose to use OTM 51 and the sniffer drone, um, it would be working with a Canadian company, using Canadian labor to do the inspections, do the studies, and it would just be running US technology in the background as far as that data collection piece and as far as the data conversion piece. Um, so there's no issues with any type of all this political craziness going on, or certainly some municipalities are required to contract Canadian labor. Um, so this model makes a ton of sense for all involved. And this is our model, is to scale our technology and allow different operators, to be able to use it. And then, lastly, just wanted to share, if the slide will cooperate, just share some contact information. So Heather is the director of sales for Canada. And, if you wanted any consultation or any project estimate, using our technology, myself, I can help out if you're looking for any technical information or, requests to see the technology. Um, you know, I'm I'm not the technical expert, but I know the technical expert. Um, but yeah, and then just finally, why autonomous data collection? Because it's more accurate, it's more actionable. We recommend that you don't wait until the regulations are in place. Okay, so we're seeing this happen in Washington State, and now they're scrambling to collect data that was required pre-regulation and to comply. So there's a lot that you can do now without penalty. And certainly we can share some sample reports, or if there's anything else um, that we can do for you. One thing I think I neglected to mention is we are the only provider of the sniffer drone that is approved in that method 21. But certainly if you need multiple estimates, um, OTM 51 is just a different way to collect the data as part of method 21. So you could certainly solicit multiple estimates and make a determination if OTM 51 is the right approach for you.
Hey, Robert, thanks very much for your presentation this morning. I really appreciate you doing it. And I know, Richard, you um, brought it, so close it off. And then following this, Richard, we'll go for a 15-minute coffee break.
Yeah, thank you, Robert. Could you share your presentation with us?
Yeah, I'd be happy to do that.
Send that to Debbie, and then she can post or share it with the participants.
Yeah, be happy to do that.
Terrific. Thank you so much for short notice coming in and helping us out with your presentation.
Yeah, my pleasure. I hope this was helpful and insightful.
Thank you.
Great. So, Richard, I have it being 10:40, well, 10:39, but it'll be 10:40 in a second. Let's, if everyone doesn't mind, let's meet back here in 10 minutes at 10:50, and then we will go on with the next section, which you're up for. Okay, Richard?
Yep,
Great.
sounds good.
See everybody
Thanks,
in 10 minutes at 10:50.
Thanks again, Rob. Bye.
Yes, thanks again, Rob.
Maybe Rob, you can stop sharing. Terrific. Thanks.
Richard, you're gonna do the leachate and landfill gas section, right?
That's correct. Yeah.
Yeah, because I'm completely done with mine, the last one, so we're good there.